Let's understand the stack operation and its implementation. So we try to understand this stack operation with the help of array. You can apply this stack also in case of linked list or any other data structure. So consider we will use here array, and this array will be stored in the form of stack. So in this case we are representing the stack operations with the help of this array, and the name of this array is stack, where the size is 4 and the indexes are 0, 1, 2 and 3. So stack is having one unique property, and that property is last in first out. It means the element that will store into the stack last will be take out first. So let's first try to understand the insert operation in stack in this array. So let's say we insert one number in this stack. So basically we are inserting the number 12 at the index 0. So it is the normal insert operation in case of array. Now in this case we keep track of the latest number index that is inserted into the stack. So the latest number that is inserted into the stack is 12 and its index is 0. So we keep track of the indexes of the latest number that is inserted into the array. Now let's say we insert another number in this array, that is 15. So the index of this number is 1. So we have to keep track of the latest number that is inserted into the stack. So the latest number is 15 and its index is 1. So this is the insert operation that is happening. It is a normal insert operation in case of an array also. The only thing is we keep track of the indexes to those number which is latest in this particular array. Now let's say we insert another number. So we insert here 5 and we keep track of index. So basically the top of this particular array, the top index is 2, where we have the number as 5. So we always keep track of the latest number index and we call it top. So basically this top is nothing but the variable that keep track of the latest number that is inserted into this array, and the name of the array is stack. Or you can say in case of the stack terminology, we always keep track of the index of the top of the stack. So this is my stack where the index of the top of the stack is 2 and its value is 5, and this top variable will always keep track of the index of the top number in this stack. Now here we are inserting it, but in case of stack terminology we call it push operation. So basically whenever we are inserting a number into any kind of a stack data structure, then we call it push operation. So as we showed you that when we insert the number into the stack, we increment the value of top also. So these are the two operations that happen in case of stack, and this is the push operations, and this operation will take O of 1 time complexity. So this operation is pop. This is my top, which always keep track of the top of the stack. Now similarly, let's see the delete operation in case of stack. So whenever we want to delete a particular number from the stack, we first take out the number from the top of the stack and then decrement this variable. So now this variable top is right now pointing at the index 1. Previously it was pointing at the index 2. So first we take out the number that is on the top of the stack and then we decrement the value of top. So now right now top is pointing at the index 1. So this is the delete operation that happens in case of stack. And in stack terminology we call it pop operation. So when we insert it we call it push, and when we delete it we call it pop, and these both operation will take O of 1 time. So if you noticed here we are using the last in first out operation. How? So in the top of the stack previously we have 5. Now the 5 is the latest number that is inserted into the stack, and once we perform the delete operation we take out the latest number from the stack and then decrement the value of top. So we are performing the last in first out operations. The number that is inserted last will take out first. So that's why in case of stack we always perform the last in first out operations. And similarly we have the push and pop operation. Like currently